You know, there's a technology that's quietly rewiring our digital world from the inside out. It's called co-packaged optics, or CPO for short, and it's a massive shift. We're moving from using tiny electrons to using photons, yeah, light itself, to build the entire future of computing. To get a sense of just how big this is, just look at this number. By 2030, the market for CPO is expected to hit $583 million, and it's growing at a blistering 38% every single year. A number that huge doesn't just suggest change is coming, it's screaming that a massive shift is already happening right under our noses.
So, you gotta ask the question, right? Why now? Why are all the biggest tech companies in the world suddenly scrambling to adopt this completely new way of connecting computer chips? What problem is so massive that it requires us to reinvent how our data centers even work?
Well, the answer, in a nutshell, is that our insane, insatiable hunger for AI is pushing our current tech to its absolute breaking point. We have hit a wall, a big one. I mean, just look at this contrast. It's a tale of two worlds. On one side, you have our traditional tech, which is already straining at the seams. And on the other, you've got the monster demands of modern AI. We're talking models with over 1 trillion parameters that all need to talk to each other, like right now. This crazy mismatch is creating a data traffic jam of epic proportions, and maybe even more important, an energy crisis inside the very buildings that run our digital lives.
I love this quote because it just nails the problem perfectly. The river? That's the colossal, unbelievable amount of data that AI needs. And the garden hose? Well, that's the copper wiring that connects all the chips in our systems today. It just wasn't built for this. We need a much, much bigger pipe.
And that bigger pipe, well, it turns out it's made of light. This brings us to the hero of our story, co-packaged optics. This is the breakthrough that's designed to just smash right through that data wall and solve that energy crisis.
So what is CPO, really? The simplest way to think about it is this. It's all about closing the distance. Instead of having these separate, kind of clunky modules that turn electricity into light, CPO puts the light-making engine right next door to the processing engine. They become roommates, all inside one tiny, neat little package.
And here's why that's so brilliant. In the old systems, an electrical signal has to travel several centimeters over copper wires. And with every single millimeter, it loses energy. It gets weaker. CPO just slashes that journey from centimeters all the way down to millimeters. And that tiny, tiny change, it's everything. A shorter path means a cleaner signal, and you guessed it, way less wasted energy.
And boom, here's the payoff. You can see it right here. The energy savings are just dramatic. By making this one switch from the old pluggable modules to CPO, data centers can cut the power they use for just their network connections by up to 50%. That's not a small tweak. That is a genuine game changer, especially if we want to build AI that's actually sustainable.
Okay, so bringing light and silicon this close together is obviously a revolutionary idea. But how on earth is it even possible? Well, the secret sauce, the magic behind it all, is a manufacturing technique called heterogeneous integration.
And the best way to think about heterogeneous integration is to imagine you're building with the most advanced microscopic Lego bricks you can possibly imagine. Each little brick is a totally different material with a totally unique job. So this brick is your silicon processor, this one over here is your light emitter, another is your memory. CPO is basically about finding a way to click all these different Legos together into one single super powerful unit.
But, and this is a huge but, this is not a simple Lego set. It's an immense engineering challenge. You're trying to bond materials like silicon and something called indium phosphide, and they react to heat so differently that they can literally tear the package apart. They have to be stacked with mind-boggling precision, all while trying to pull a ton of heat out of this tiny, dense space. And a challenge that big, well, it can't be solved by one company working alone. It takes a whole ecosystem, a whole village of specialists, all working together to make these high-tech Legos a reality.
Let's just look at a quick real-world example of this. You have a company like Tower Semiconductor, and they provide the foundational factory, the platform, to actually make the chips. Then you have Latitude Design Systems creating the software, the blueprints, to make sure all the parts talk to each other correctly. And then you have pioneers like Wave Photonics, who are using AI to design the custom optical parts faster than any human ever could. It's this beautiful collaborative loop.
Okay, so we've seen the problem, we've seen the solution, and the incredible engineering that makes it all tick. But what does it all mean for us? You know, where is this technology actually taking us?
And listen, this isn't some far-off science fiction dream. The revolution is happening on a very clear, very fast timeline. We're talking commercial use starting as early as next year. By 2027, the next generation of data centers will be built around this tech. And by the end of the decade, if you're building a serious AI system, these light-speed connections won't be a nice-to-have, they'll be the absolute standard.
And the impact won't stop at the data center door. The same ideas, low-power, super high-speed optical connections, are totally essential for what's coming next in mobile communication. Think about truly immersive VR, instant communication. All of that is going to be powered by the next wave of 5G and 6G networks built on this exact technology.
So what this all really means is that we are fundamentally rewiring our world for an age of AI and light-speed communication. And that leaves us with one last, pretty fascinating question. We're solving this incredible challenge of building faster, better connections between machines. With all that power, what new connections will we build between each other? Thanks for watching.